Namaskaram. In this session, we will see the evaluation of volume using triple integration, the solution of last formula. In our second problem, our region of integration is this solid. Okay, intersection of this z is equal to 2 minus x square, a parabolic cylinder, and y is equal to x is a plane, this blue plane, and this is our this green one is plane y equal to 0, that is x z plane, right? And last one is z equal to 0. So the region bounded by all these planes and this parabolic cylinder is this portion. Okay, so we have to integrate over this portion. It's clear that here our z is varying from this point to this point. The lower value of z is 0 and upper value from this parabolic cylinder. So what is the value of z? Z is equal to 2 minus x square. Clear? And we have to move this strip along the region, this triangular shaped region, And what is the equation of this portion? This is nothing. This is the intersection. This line is intersection of parabolic cylinder with our xy plane. That means z equal to 0. So when z equal to 0, what happened? When z equal to 0 on this equation, that gives the intersection of this parabolic cylinder with the xy plane. So that means when z equal to 0, this is 0 equal to 2 minus x square. So x square equal to, so x equal to root 2 or minus root 2. Okay. So this is the positive direction of x-axis. So the equation of this line is x equal to root 2. And similarly, this parabolic cylinder has one more intersection, that is this one, this intersection. That is x equal to minus 2. Okay, that's why equation of this portion is x equal to root 2. And this side is nothing, this is our y is equal to x. Okay, then you can easily form this integration. That's all. Okay, first we are going to develop a formula for evaluating a volume using triple integral. And we know that triple integral over a solid G or for f of x, y, z dv is equal to this infinite sum. Okay, and we know that delta Vk is the volume of kth element. Okay, suppose we have to find this green solid, let it be G. Suppose we have to find the volume of this green solid. Then how to find the volume? You simply evaluate limit n tends to infinity sigma k equal to 1 to n delta Vk, right? Because delta Vk is the volume of kth sum. You take the sum of all such volumes and take n tends to infinity. So that gives the volume of the solid. That's the idea of evaluating the volume. So volume of solid G is equal to limit n tends to infinity sigma k equal to 1 to n delta Vk. So what is our function? So here function is 1, right? So what is the equivalent triple integral form of this representation? If this is the representation, this is the formula, then this is the representation. Here instead of what is our f of x? In this case, our f of x k star, y k star, z k star is 1. That means our function is throughout 1. So this infinite sum is of the form like this, triple integral over G 1 dv. Okay, so we can find the volume of a solid G using this formula, triple integral over G 1 dv. Okay, consider a problem. Find the volume of the solid in the first octant bounded by the coordinate planes and the plane 3x plus 6y plus 4z equal to 12. Okay, so first we have to plot a rough sketch of this solid. So we know that coordinate planes, this is our xz plane, this is yz plane, this is our xy plane. That's clear. So what about this plane? It is clear that what is the intersection of this plane with the x-axis? Okay, to find the point, you can simply substitute y and z equal to 0. So if you substitute y equal to z equal to 0, this gives intersection of this plane with the x-axis. So when y equal to z equal to 0, this become 3x equal to 12, so x equal to 4. So the meeting point at x-axis is 4. Similarly, you can find meeting point with y-axis and meeting point with z-axis. How to find the meeting point with y-axis? By substituting x equal to z is equal to 0. So that means 6y equal to 12. So y is equal to 2. So the meeting point is 2. And similarly, you can find the meeting point with the z-axis by substituting x and y are 0. So if x equal to 0, y equal to 0, this becomes 4z equal to 12. So z is equal to 3. So this is the somewhere meeting point. So now almost clear the shape of the plane. So almost like this one, a slanted plane passing through these 3 points. Okay, and bounded by these 3 coordinate planes. So this solid region is our G. So we have to find the volume of the solid region. Okay, I will show the exact shape of this solid like this. Okay, this blue one is our slanted plane passing through 3, and here it is 2, this is 4. Okay, and this is our xz plane, and this red one is our yz plane, and this one is our xy plane. Okay, and so we have to find the volume of this blue shaped solid. Okay, so how to set up the integral? Okay, we know that volume of a solid is equal to triple integral over G 1 dV. Okay, next we have to find the limits of all the integrals. Okay, first we have to find the range of Z. It's clear that Z is always starting from XY plane. Okay, up to this blue plane. Okay, so the lower value of Z is 0, and what is the upper value of Z? Upper value of Z from the blue plane. Blue plane means this plane. So you can easily find the Z value. Sorry. From this equation, 4z equal to 12 minus 3x minus 6y. Then z is equal to 3 minus 3 by 4x minus 3 by 2y. Okay, 3 by 4 means 0.75 and 3 by 2 is 1.5. Okay, so we can write this integral as this is 3 minus 0.75x minus 1.5y. Okay, this is the upper limit of z. Okay, next we have to find the range of x and y in our region R. What is our region R? The projection. The projection is a triangular region. So we have to move this vertical strip along this region. Okay, so we can redraw the vertical strip. We can redraw this triangular region. In x-axis this is 4. In y-axis this is 2. Okay, so we can redraw this one like this. In positive x-axis, the touching point is 4. In y-axis, it is 2. So we have to integrate over a triangular region like this. This is our R. This is our R, this region. Okay. To integrate over this region, we have to find the equation of this line. Okay. How to find equation of this line? It is clear that this line is the intersection of this blue plane together with our xy plane. So intersection of this plane together with the xy plane means you simply substitute z equal to 0 in this equation. So when z equal to 0, this equation of the plane becomes like this: 3x plus 6y is equal to 12. So this is the equation of this line. Okay, intersection of blue plane with the xy plane. Xy plane means z equal to 0. That's why we substitute z equal to 0. Okay, so it is clear that this is x plus. Okay, this is you can divide with the 3. So this is 3x plus 2y is equal to 4, and from this equation x is equal to 4 minus 2y. So this is the equation of the straight line. This straight line. Okay, so this is nothing. Our x is equal to 4 minus 2y. Now you can easily set up the double integral. Okay, suppose you consider a horizontal strip like this. You have to integrate over this region. What is the lower value of x? That is 0. What is the upper value of x? 4 minus 2y. So this becomes 0 to 4 minus 2y. Okay. To cover this region, what is the range of y? Y is varying from 0 to 2. 0 to 2. So this is the setup of this triple integral. Okay. Now you can easily evaluate this triple integral by integrating. Okay. So one more thing. What about this one? This is the limit of x, right? So the order of integration is dx dy. So you have to evaluate in this order. First you integrate with respect to z, then with respect to x, then with respect to y. Okay. Okay, so integral of 1 with respect to dz. So that is z 0 to 3 minus 0.75x minus 1.5y. Then next you have to substitute the upper limit. That means when z equal to 0, the term is 0. So this becomes 3 minus 0.75x minus 1.5y dx dy. Next you have to integrate with respect to x. So what happened? So this becomes 3x minus 0.75 x square by 2 minus 1.5 y into x. 0 to 4 minus y. Next you substitute upper limit and lower limit. When x equal to 0, all the terms are 0. Okay. Okay, so this become 3 into 4 minus 2y minus 0.375 into 4 minus 2y whole square minus 1.5y into 4 minus 2y. Okay, when x equal to 0, all the terms are 0. dy. Next you have to expand this 4 minus 2y whole square and you can simplify it. Also you can expand this bracket. Okay. So expand all the brackets and simplify. So this become, the integrand become, so upon simplification this integrand is like this, 1.5y square minus 6y plus 6 dy. Okay, so next you have to integrate with respect to y. So this become 1.5 y cube by 3 minus 6 y square by 2 plus 6y, 0 to 2. Next you have to substitute the upper limit and lower limit. When y equal to 0, all the terms are 0. So when y equal to 2, this is equal to 1.5 into 2 cube, that is 8 by 3 minus 6 into 2 square, that is 4 by 2 plus 6 into 2. On simplification, this becomes 4 minus 12 plus 12. So this is equal to 4. So volume of the solid, this solid is 4. Okay. Okay, this is your homework. Thank you.